Hi, you are welcome in the image classification video tutorial series, and in this video we'll talk about the principal component analysis. Down is something about me. I'm Dr. Zubairul Islam. I'm working in the Department of Geography at Igrat University. So ArcMap is open, and left hand side is the data and right hand side is the toolbox. Let me introduce my data. This data belongs to the Adigrat, and in this data you can see here there are 5 bends, bend 1 2 3 4 5, and the data is Landsat 8. So this time this is the natural color image, and if you are giving the near infrared band to red channel, then you can see this is the false color and the red areas is the vegetation. So what happens, sometimes we need to classify our image to find some important, the distinctions, some important features which are not visible even with the help of color combinations like true color or false color. So what we do for that very purpose, we use principal component analysis. And principal component analysis lies within spatial analysis tools, then multivariate toolset, then principal components. We'll click the principal component analysis here. Thereafter we will give the image and how many principal components you want here. Default is the number of bends, but let's take 5. Okay, and if you want output data file, then you can give the location of output data file here. The name can be piece principal component analysis, and let's do it. Okay, so in the process, let me explain you little. Is here we have the number of bends, and these number of bends are around 5. And now you see the software has classified the image, and if you compare your PCI here, you see how much distinction and differences are there. So these differences are because of the statistics is applied here. You can see PCA, and you can find the input raster is my data, number of components are 5, output is there, and what statistics is being used for this analysis is the software is calculating the covariance, software is calculating the correlation, and the principal component tool is used to transform the data in the input bands from the input multivariate attribute space to a new multivariate attributes space whose axes are rotated with respect to the original space. So the axis means the attributes in the new space are uncorrelated. So what happens actually, the main reason to transform the data in PCA is to compress data by eliminating the uh, redundancy. So where what is happening here, if you will see AST, if I take the data 1 only, let's take red, or we can take here apply. So this is the band 1. Band 1 is giving you some information, okay. Similarly you can see another bands also. Band 1, 2, apply. This is band number 2, this is 3 and 4, and here is 5. So there is a drastic change in band 5 and band 4 because this is band 5 here, and if you will see the band 4, the values will be changed. And here band 4 and band 5 both are important. So in PCI, what it will do, because the values are nothing but the information, source of the information. Some of the values are very important because those values are giving us the information, like band number 5 is giving the information of vegetation. Band number 4 may give the information of another feature on the surface of the earth. So whatever important, if you will take all the images, 5 images, then each image will give you some more information with some varieties. So those varieties are chosen by the principal component analysis, and the information, the data, which is not much important, so that data is eliminated. The common data is eliminated. So for an example, if you see the data redundancy, means we can understand that if we have the multi-band raster, and that raster comprising the elevation, slope, and aspect on the continuous scale. So if you will see the elevation, slope, and aspect, so what happened? These aspects and slopes are derived from the elevation. So most of the variance within the study area can be explained by the elevation. So elevation data is important because it is giving us much more information. So the result of the tool is a multi-band raster in PCI with same number of bands as specified the number of components. So if I gave the number of components here 5, then you can see here there will be the five uh, 5 bands here. Okay, so these 5 bands, you can use the 5 bands. Maybe you can use 5 bands here. Okay, so where you find something you need, then that thing you can take in your study. So this is the way you can calculate the you can use the principal component analysis. And you can study the different features within your study area. So here the importance to some of the things are important, like here the EGN values. Here these are the layer 1 2 3 4 5 1 2 3 4 5. So covariance here. This is the correlation matrix here. Correlation 1 to 1 will be 1, 2 to 2 will be 1, 3 to 3 will be 1. Rest 4 to 1 is 0.93. Okay, the least is 5 to 1, that is 0.25, because this nature is different of band 5. Band 5 is the near infrared band. So the correlation of band 5 with another band is totally different from band 1 2 3 4. So 1 2 3 4 is the reflective bands, the nature, in spectrum, electromagnetic spectrum, you can say that this is the area of visible part, and this is the near infrared part. So this is the reason NIR is different from rest of the bends. And if you will see the covariance, then this is, you can see in text format, then you can understand that this is like the values will be meaningful for you. Then agent values are calculated here, which is are given like 1 2 3 4 5 1 2 3 4 5, and agent vectors are also given here. uh, these vectors will help you to understand the directions, and this is the percent and accumulative agent values. So this was about the principal components uh, analysis. In the next video, we'll talk another aspect of image classification. So thanks for listening and thanks for watching.